The views and opinions expressed over the following hour of programming do not necessarily reflect the views or opinions of the University of Alberta, its Students' Union, or CJSR. Quite often, they don't even represent the views of the hosts of Skeptically Speaking, that show which is coming up next, so stay tuned. Hello, listeners. Welcome to the show where we dig deep into the mysteries of the world, uprooting facts and proving knowledge, so that you may call in and question everything. Skeptically Speaking starts right now, so take it away, Des.
Thanks, Sean. So today we'll be speaking about geology with Dr. Hans Machel. We'll be getting into things like hollow earth theory, the healing power of crystals, and the claim that our planet is only 6,000 years old.
All true?
No. You're on the wrong show. But let's talk about something first that happened recently in the world of science. Now, I hope I'm saying this right. It's Darwinius Machel, maybe? But anyway, the nickname is Ida. It's a 47-million-year-old primate fossil, and it has taken the world by storm.
Even Google used it as their little search image.
I saw that. Yeah. That was adorable. And that's because, A, she is incredibly well preserved. She is a she. That's how well preserved she is. And,
does she still look young for her age?
She does.
Excellent.
She's awful. I knew that was coming too. And B, there are two broad groups of primates. Now, I'm going to mangle these words. It's anyway. No. Anyway, two broad groups of primates. One includes little guys like lemurs, and the other one includes animals like monkeys and humans. So Ida has characteristics of both. Now, that apparently makes her the missing link and proof of evolution. And I say bah.
Bah.
First of all, there's already been a ton of evidence for evolution. This is not the first piece. If you want to look for more evidence, my favorite personal one is the E. coli experiments. They're fascinating, and I'll post a link after the show. And I was reading Pharyngula, the wonderful blog Pharyngula. He puts it, the whole missing link category is a bit of journalistic trumpery. Almost every fossil could be called a link, and it feeds the simplistic notion that there could be a single definitive bridge between ancient and modern species. There isn't. There's the slow shift of whole populations which can branch and diverge. So yes, it is a wicked cool fossil. We should all be very excited. But the way that the media has portrayed this really rubs me the wrong way. It's given non-sciencey people the impression that anyone who studies evolution was just kind of sitting around, waiting,
twiddling our thumbs,
for this to show up to go, oh, see, that's what we were talking about, which is totally not the case. I've actually had people come up to me at work and say, wow, you must be really excited. Like, this is my own personal find. And congrats, Des. They proved what you've been saying. I don't know.
Your life's research right there.
I know. I'm very confused. And I don't want to have a long, kind of drawn-out conversation about why it's not as cool as they think, because I'm happy that the story has made it into the mainstream at all.
I kind of wonder if it's a good thing if people are now under the assumption that evolution is really true. Would that be so? I know it's under false pretenses, but
it is.
It's a little bit that pushes them over the edge to really get it.
Maybe a couple of people will be in that boat, but I think this also gives fodder for the creationists in another way to say, see, all that other stuff that they were purporting was true, totally wasn't true. Now they're saying this is true. We can't believe anything those people say.
And of course, there's every time you fill a gap, you create two on the left and the right. So they'll say, oh, well, what bridge that? And
this is, look, I understand that we have to sex up science to make it palatable.
Well, that's why we have you two on the air.
Yeah, Sean's getting brownie points. But, I don't know. I don't know if this is the best way to do it. So, from celebrity fossils, let's go to actual celebrities. We're in studio with skeptic Jill Powell, who is angry about something.
No.
Welcome, Jill.
Hello.
Rant away.
Why, thank you, Des. Today I want to discuss celebrities who dispense medical advice to the public who really, really shouldn't. Specifically, I want to talk about Jenny McCarthy and her anti-vaccination crusade. So I want to apologize in advance if I start to sputter angrily in the middle of my sentences, because I am really riled up about this. As part of my research this week, I had to watch a video of Jenny McCarthy and Jim Carrey on Larry King Live.
The things you do for science.
I know, right?
Constantly inspiring.
A very interesting point at the beginning of the video is that they claim that they're not anti-vaccination at all. They're not. But then in the same breath, they say vaccinations are harmful to children everywhere, and they cause autism.
Right.
So, no, you can't say that and then just go right and prove what you just, it's very frustrating. And then they go on about all the toxins that are in vaccines, which is basically them combing through the ingredients of vaccines, seeking out the studies that found the adverse effect level, and then cite these studies as proof of that the ingredient is toxic. And they both seem to think they know more about medicine and science by just using Google extensively and personal anecdotes rather than scientists who have spent their entire adult life studying and researching these very things. And they are also very quick to absolve any blame upon themselves if parents, from listening to Jenny McCarthy go on and on about all these toxins, decide not to vaccinate their children, that, oh, surprise, their children get sick, and then, oh, they die.
And other children get sick and die.
It's
due to you're destroying the herd immunity. Yeah, absolutely.
And a direct quote from Jim Carrey is, "We're not the problem, they're the problem." They're meaning vaccines or big pharmacy corporations that churn out this evil plan to hurt more children. And because it's not that the anti-vaccinationers are wrong, it's that everyone else is wrong. And those who don't, with the bile that they're spewing out, is part of a huge conspiracy theory against them. Neither of them have any educational background or medical license to give any type of medical advice to any medically related topic to any parent.
That's what I find so interesting, is the fact that celebrities are now experts on things. That's frightening. And in the same line of thought, experts are treated like pariahs in a lot of ways.
Because they don't look like House or McCoy. It's true.
We could totally talk about House and McCoy.
Yeah.
Okay. No, but we're not.
No, we're not going to do that.
Well, we would be missing out on Spock. I'm just going to put that one out there.
Oh, Spock,
okay.
Of course.
Okay, we're getting distracted.
But Jenny McCarthy is also fond of saying that autism is caused by vaccines because she just knows. Well, sorry, Jenny, but science isn't based on a feeling you get in your gut. Science is based on tests, not just one test, a lot of tests. If you're going to be a spokeswoman, you need to know what you're talking about and do actual research, not just picking and choosing parts of articles that bend to your belief. So that's what gets me so angry, because there are actual scientists who are doing test after test trying to say, okay, we've done this test to prove that there's no correlation between what you're talking about, but they don't listen. They're like, okay, well, they've proven that, but let's jump on this because they haven't proven that yet. And now that we're going to have to waste more money that could be used on something else that, I don't know, has bigger meaning than this whole anti-vaccination craze that's going on.
And it is a craze right now.
It is.
But that being said, so of course, yes, people, use your brains, don't listen to celebrities
the key
about
is just
medical advice.
The key is to be skeptical about everything you see and read. Check the sources.
Well, on that, in that light, though, how about someone like Amanda Peet? Now, she has the right idea. She is pro-vaccination. She's come out against Jenny McCarthy. So how do we feel about stuff like that? We don't want celebrities talking about things they don't know. And, it's fantastic that Amanda Peet is, on the side of,
reason.
Logic. Exactly. But do we want that? Are we really expecting people to now research which celebrities know what they're talking about?
Well, and I don't believe that is, because it's easier to just take what the celebrities say for truth. It takes a lot of work to do research. Hello, this is what I've been researching all week. My brain is going to explode.
But shouldn't we believe things that all pretty people say? Like, they're...
Absolutely.
Isn't that
because obviously that's linked with knowledge.
Of course, prettiness. This is the new slogan for Skeptically Speaking. If you're ugly, we're not going to believe you. So
Right. Good. Yeah. Evidence.
But, I guess what it comes down to is we don't want celebrities to use their popularity when we disagree with them, only when we do agree. I think that's a really hard line to to kind of straddle there, because of course you want someone to be able to be on your side who's in the spotlight, but
Absolutely.
at the same
time, to use their celebrity for good.
Not evil, Jenny. So, but I guess when it comes down to it, because we can't control who people are going to listen to, I guess that if the celebrities are on the right idea, I would rather people listen to Amanda Peet than Jenny McCarthy. If we had to go down that route,
if they're going to listen to someone,
listen.
I'd rather it be Amanda Peet.
It's
okay.
Very true.
That's fair. That's
yes.
a T-shirt.
Really?
Oh yeah, right there.
Yeah,
I would wear that.
Oh, I thought you were saying
you are like a
Not yet.
professional T-shirt creator now, so you can probably scam something else for free
True.
for having.
I don't know if anybody watches me on Twitter. You already know this.
And if you're not following her on Twitter, tisk tisk.
Yes, true.
You can find me at @skeptic. That's TH_skeptic.
TAEH.
That's what I said, didn't I? Anyway,
I guess my biggest point to this whole thing is just because you're on the cover of People magazine doesn't mean you know more than that guy who you know went to medical school. Just because you're in the spotlight, maybe you shouldn't run your mouth off, because people are going to listen to you, especially with something as horrifying and heartbreaking as autism, especially for a mother. Of course, mothers are going to listen to this because they will do anything for their child. And that's fear-mongering, and that's playing off their fears and their sympathies, and that's despicable to me. I just think that's wrong. So.
And on that note, thank you very much, Jill.
Thank you for letting me rant.
Oh, I love when Jill rants.
Yes, it's always a pleasure to have you here, Jill.
So we'll be right back with an interview on geology right after the break.
Here at Skeptically Speaking, we encourage you to call in and question everything. During tonight's episode, you can call in at 780-492-CJSR, extension 1, to join in on the conversation. Again, that number is 780-492-2577, extension 1. If you're a little bit shy, please email live@skepticallyspeaking.com or send us a short message to Skeptical Radio on Twitter. After the show, feel free to comment on tonight's episode at skepticallyspeaking.com, where we also make this and past episodes available as a podcast. We'd also love to see you join our Skeptically Speaking Facebook group, or have you follow Skeptical Radio on Twitter. Of course, if you want to give us feedback the old school way, you can also email us at feedback@skepticallyspeaking.com.
We are in studio with Dr. Hans Machel, born and raised in Germany, who's been a professor of Earth and Atmospheric Sciences at the University of Alberta since 1987. He received his PhD in geology from McGill University. He's published more than 100 technical papers on various subjects and received several awards for his scientific work. He is also a longtime skeptic. Thanks for being with us, Hans.
Thank you for inviting me.
So when I say long-time skeptic, how long are we talking here?
We're talking since about 1986, when I first stumbled across the magazine called Skeptical Inquirer, which I've been a subscriber to ever since. And as you've just said, I've been teaching since 87, and I've actually from day one included skeptical thinking in my teaching. So I don't just teach my students facts. I teach them how we arrive at such facts. How do we know, let's say, the Earth is 4.6 billion years old? How do we know how big the Earth is? And things like this. You know, just not just transmit facts and write down, oh, this is this is that, and regurgitate it in an exam. But how do we actually find out about these things? And that is just, easily this entire subject of skeptical thinking of, how do you find out how, let's say, how old the Earth is? Things like this. I've actually brought you a cartoon here, a little sketch, and if I may, I'd like to explain this because I think it's a good base for our discussion here. I call it the Square of Irrational Thought. So anyone at home who listens to this show can imagine this because it's really simple. It's a square. In the middle of the square, it says bullshit. And basically, this is a less than polite way of saying here's an irrational thought, something that you cannot really substantiate with rational thinking. And well, how do people come up with bullshit, right? There's 4 types of people. First group of people, they are really stupid. And in plain English, they just don't have the brain power to formulate a rational thought. And that's more or less hardwired. There's nothing you can do about it, not with adults anyway. The second group of people, and this is by a long shot the largest of these four groups, they're naive. And what that means is they are not necessarily stupid, they just don't have the necessary information or experience to make a rational conclusion about a certain phenomenon. And this is gradational. You could be a smart person and very literate about a certain subject, let's say, I don't know what, nuclear physics, but you could be very naive about medieval architecture. So naivety and stupidity are somewhat related, in that naive people are not necessarily stupid, but all stupid people are necessarily naive. And then there's two other groups. There are people who know better, but they are liars. They just sell something that is demonstrably wrong, that's bullshit, either for political gain or for monetary gain. And there's a whole bunch of people like this who, for example, sell water dowsing, with these divining rods or little pendulums. Or a few days ago, there was a woman in the Edmonton Journal who somehow changes the energy in a room with a little bell. So she goes in there and rings the bell, and somehow then the energy of the room is better. That's bullshit. I don't know if she's stupid or if she's lying, but she certainly makes a lot of money with this, right? So this is the third group. That's the liars. And then there's a fourth group of people who are delusional. They are, if you wish, they're really mentally ill. There's something wrong in their, in their chemistry in their brain, and they could be fixed, either with counseling or with drugs or with education or any mixture thereof. But you really can break it down to these four types of people with a little bit of overlap. So when we're talking about, things like, I think one of the things you mentioned was the hollow earth theory, when somebody says the earth is hollow, then ask yourself, is that guy stupid? Is that person naive? Or is he deluded? Or, what is then you get to the core of it. And this is how I start my classes. I just don't tell my students facts, but I first query them, like, be skeptical. Query everything that I tell you. And if you're not sure how does this guy arrive at this particular statement, raise your hand and ask me. Because students have they're naive for the most part. They're not stupid. Oh no, most of my students are quite smart people, but they're naive. They need information, they need a bit of impetus, and then they come to the rational conclusions, either at the end of the semester or a little bit later.
Audience, this interview is going to rock. You can call in at 780-492-2577, extension 1. You can also reach us at live at skepticallyspeaking.com, or if you tweet, it's at Skeptical Radio.
And we just got a tweet from Null Session. He said he enjoyed the first interview, and we always like to hear from people over Twitter during the show, so please tweet in.
Absolutely. And also those of you who were tweeting questions and comments to my own account last week, don't. Thank you.
Sean doesn't see them.
Sean doesn't see them, and I don't have my laptop in front of me.
Oh, and sorry, just to throw in too, Null Session, he's in Iowa.
Oh, very nice.
Yeah.
We're trying to track exactly who's listening from where. So please do let us know. So what else would your first year students learn, really briefly? Well, besides, the basis of critical thought, which
right.
is lovely.
The basis of critical thought is the first two lectures, and this is really the basis, as I see it, for an entire university education. I don't do that with students in 400 or 500 level courses, but the beginners, they all get that, no matter what the subject is. And the subject then is, in the first 2 years, the courses anyway that I teach, basically everything that starts with the origin of Earth, the solar system and Earth, goes through the entire history of, what happened to the Earth with plate tectonics and the continents growing and earthquakes and all that, all the way to the recent, to, volcanic disasters, to tsunamis, and, of course, to global warming. We are, after all, the Department of Earth and Atmospheric Sciences, and we actually claim to this, put a claim to this title. We teach everything that is Earth and atmosphere and ocean. And all of that is covered in my classes. And you do come across certain things that are, in the pseudoscientific realm, as I said already a little bit earlier. For example, when I cover groundwater, How does groundwater move? You get into this topic of water dowsing. For that matter, there are people who douse for archaeological artifacts. There are people who douse for the gender of an unborn baby.
Yes.
There's all sorts of bull dada like this out there, and I veer into these things, and my students greatly enjoy whenever there's a little bit of a distraction, and this serves as a distraction as much as an education.
So in a first-year course, would they learn about things like radioactive dating?
Oh, you bet. That is one of the fundamental cornerstones of how do we know how old the Earth is.
So can you explain that concept briefly?
Yeah. In a nutshell, which is not easy because this is a big topic, but in a nutshell, elements in nature come in stable and in unstable forms. And the unstable forms are the ones we normally call radioactive. And basically, an element that is radioactive decomposes spontaneously in one of two ways. Either they emit little particles, because elements are composed of smaller particles, like protons, electrons, neutrons. So either they just give these little particles off, or they give off radiation. In either case, you have what we call an isotopic change or radioactive decay. And the point is this. We know the times that it takes for a so-called parent or mother isotope to decay into a daughter. So at time zero, you have 100%, let's make it really simple. Let's say there were 100 atoms of the mother. And after 10 days, these 100 atoms have decayed into 100 daughter atoms. So then the parent, the mother, is completely gone, and you have only the child, the daughter. Right? But any time in between, after 2 or 3 or 4 days, you have proportions of the two. You have so many mother atoms left and so many daughter atoms formed. And that's the basis of radiometric dating. You go into a subject or, some kind of a substance. It could be a rock. It could be a piece of bark of a tree. It could be bone. It could be all sorts of things. You measure the ratio of these two isotopes, and it tells you how old this thing is. And that's how we date rocks. That's how we date, as I said, archaeological artifacts or bones of deceased persons. All sorts of things you can date in this fashion.
For example, the Earth. Now, there are some people who believe that it's only 6,000 years old.
Yeah.
What does science tell us?
Well, you want to go back to that cartoon that I drew. Do you think these people are stupid, they're naive, or they're liars, or delusional? I mean, it could be a mixture of all of them. But all I can tell you is these people don't know what they're talking about.
Okay, well, one of their arguments is that the dating methods that we're talking about, now, you mentioned radioactive dating, but even ice core dating, that these methods are prone to error. And so they can't be well, first of all, they're either prone to error or they're not that specific. So what would you say to that?
This is sort of a cop-out, trying to basically weasel out the hard science. Every physical or chemical method is prone to error if you take it this. In other words, if I, were to say, tell me how heavy you are, what's your weight? You could put your body on the scale, and then you see the scale, it says, I don't know what, maybe 65 pounds or kilograms, whatever it is. But there's a little error attached to this because the scale may not have been calibrated properly. One day you eat a little more, you eat a little less. There's a bit of a wiggle room. This is the analytical error. So if I give you a rock age, let's say there's a rock that I've dated at 965 million years. There is an error bar attached to this that is maybe plus minus 20 million years. That sounds like an awful lot, but nevertheless, this thing is 900-something million years old, and not, as these biblical creationists would have you, 4,004 years ago, on October 23rd, at 9 o'clock in the morning, the Earth was poof, This is just stupid. I mean, this just defies any logic and any science that I've ever come across. And we have hundreds of thousands of radiometric dates from rocks all over the world throughout the entire Earth's history. And the oldest rocks that have been dated are about 4.3 billion years old, or 4,300 million years old. And, we somewhere haven't found quite the rock that is a little older, but the calculations we have is the Earth was maybe 300 years earlier than that, was already like an Earth. But not like today, not with oceans and atmosphere. It was sort of a glowing, fiery ball that then cooled into what we now know over these first 300 million years.
So what would the margin of error on that be?
Maximum, I would, by today's standards, maximum 100 million years.
All right, so still considerably longer than 6,000.
Oh, yeah, okay. By 2 orders of magnitude.
Okay.
Right? So 4.6 billion years is the age of Earth, plus minus 100 million years. But anyone who says 4,000 years or even 10,000 years, these people don't know what they're talking about. And it's as simple as that. They just should read up on radiometric isotope dating, and then they will come to the same conclusion, unless they're stupid. Right? If they don't have the brain power to comprehend this, then we can't help it. But a rational, intelligent person can read up on this and come to the same conclusion.
How about flood geology? That's their other big argument.
Do you mean the Noachian flood?
Yes, that one.
Wow.
The concept, for the audience that may not know, the concept based on the belief that most of Earth's geological record was formed by the flood described in the Bible. They say that the fossils are formed from animal and plant matter that were buried rapidly during the flood. And they also claim that fossilization can only take place when the organism is buried quickly to protect the remains from destruction by scavengers and such.
I guess, well...
And of course, this is the brand of creationist that doesn't just believe that fossils were put in the earth as a test.
Yeah,
which is a different kind.
Yeah, right. There's the various branches of these biblical creationists, and I'm not entirely sure how to answer this question because it's a very big question that you just raised. Mm-hmm. But let me start it, or maybe try to answer it from the vantage point that I'm taking in my courses. One of the things that I've come across that I have to cover is the origin of life. And of course, we have the biblical story. Let's call it a story for now, which, as far as literature goes, it's a wonderful little fairy tale. And, the Bible is fun to read as long as you realize that it's a fairy tale as far as the story goes. You just don't take it literally. Unless you're a biblical creationist, in which case, there was this guy, Noah, who built this boat. And, you put these 7 animals or ruminants on it and all that. The key thing is you can take that story apart so easily. And if you take that story apart, you take the entire, Noachian myth apart. Let me give you 2 or 3 examples. And I could talk about this for an hour because this is how long it takes in my classes. Start at number 1, right? How big was Noah's boat? It's actually very specific in the Bible. It's given in cubits, which is an ancient kind of a length measure. And if you translate it, the boat was about 150 meters by 25 meters by 15 meters in size. Okay, so now let's say this guy was actually capable of this engineering feat, which I find hard to believe. But let's say he could actually build a boat like this. Now, the question is, would that boat float? Here's the very simple first step you have to take. In the Bible, it says very clearly that it was raining for, remember that, 100 days, right? Day and night. I think it was 100 days, right?
40 days.
40 days. 40 days, right? Day and night.
You're looking at the wrong person.
I can't remember. Okay,
anyway.
It was 40 days, yeah.
And it said that at the end of this, torrential downpour, the earth was flooded basically all the way to the top of Mount Ararat. Now, we know how tall that mountain is. It's about 5,000 meters. So you can calculate how much water you need to go from present-day sea level up to 5 kilometers. Once you know that amount of water, then you know how fast the water has to come down because you have only 40 days and 40 nights to do this. Do you know, or can you imagine what the actual rainfall would be? This can be calculated easily. It's about 5 meters of rain per hour. Right? Do you know what the annual precipitation rate is in Edmonton? In a year, 35 centimeters. So in other words, if you actually have this boat, it's a wooden boat, 150 meters, okay, and then you have this downpour. This is like you put a tiny little boat the size of $1 or so in a swimming pool, and then you call the fire department and they take this 5-inch hose and bear down on that boat. It's going to get smashed into smithereens in no time. This boat just couldn't even survive the downpour, let alone put 1 million little animals on it, including the giraffes and the elephants. They wouldn't even fit on the boat if it hadn't floated. And then you have to worry about the food.
So
right?
This isn't even geology that's disproving this. This is math and
it's common sense.
Common sense. All right.
I mean, have you heard the elephant that they want to move out of the Valley Zoo right now? Do you know how much an elephant eats in a day? Like 160 kilograms of fodder. So we have 7 elephants on this boat, and you have to carry 96 tons of fodder along for them. Where's that going to go? You can't even fit the animals on it, let alone the food for them. I mean, it's just so absurd. How can anyone who is a rational person believe it? And you know how many people believe this story?
The majority.
One or two.
No, they're statistics. I've read the statistics. There are Gallup polls and similar polls every 2 or 3 years, and they consistently come up with numbers around 45%.
That's what I was thinking, half
of the American population. We're talking 130 to 150 million people who can't think straight, and that's putting it politely. Right? I mean, this is just so absurd. And my students understand that. I mean, they just walk out of class, they have a big smile on their face. Yeah, sure, this can't be right. And yet you turn around and half of the general population believes this crap.
Well, let's keep on the irrational train of thought. We'll leave creationists and head to hollow earthers.
Hollow earthers.
Well, I do have an email question that kind of relates from where we're coming. We talked about how the flood could potentially, or, science can explain that we find life under the depths of the earth. What is actually the most extreme depth for which we would be able to expect to find any life?
Oh, that's a very interesting question. That's a serious question. And I would have to answer this from a completely different angle. The flood is not the issue here.
Oh, no, it was just kind of a segue to get to the question.
You're a geologist.
I've actually written a paper on this very topic because I was approached a few years ago by a microbiologist and who asked me, what is the depth to which microbes could metabolize oil? Because, there's, the big tar sand or oil sand deposits are basically the result of what we call biodegradation. So there's a type of microbes that eat away at this crude oil and make it into this thick tarry substance. So one of the key questions is how deep can that be expected? And there's 2 answers to this. Biodegradation is done at about 1 kilometer of depth into the sediment, into the rock. But that's not the depth of the biosphere. The depth of the biosphere, as we call it and understand it, is basically as far down as you can go where there is no more life possible. And the best estimates are this has to be at least 10 kilometers, maybe 10, 15. Now, that is, however, this is an abstruse number to imagine, but put this in context. The Earth is a ball, not exactly spherical, but let's say for all intents and purposes, almost spherical, with a diameter of 6,300 and a few kilometers, right? This is a huge, gigantic ball. Now, if you go in about 10 kilometers, this isn't even like the thickness of the peel of an apple. This is an incredibly thin outer skin around this apple, okay? But that's as deep as the biosphere goes. And below that, it's simply too hot, and it's simply too high pressure. And last not least, if you have life, you need to have food. There's no food. So that's the answer, the hardcore questions to the answer that your reader or your listener was posing.
I think it follows up good. The second part of their question was, are there any true subterranean forms of life? And I'm not sure if they're referring to depth or maybe the hollow earth thing we're about to get into here.
People?
I'm not quite sure where they're going with this. If they just mean, the hardcore microorganisms that live deep in the earth, or if they're actually talking about mole men. Let's go with mole men. It's more interesting.
But let's not.
Well, let me answer this again in two ways. Again, the first part of the question I've already answered. The depth of the biosphere is probably around 10, 12 kilometers or so. Basically, on basis of hard evidence, we have drill cores that go down to about 12 kilometers. And by 12 kilometers, that's the deepest drill core that has ever been pulled. The sediment, the rock rather, is maybe 200, 220 degrees hot. Basically, what happens is at that depth and at that kind of stress, the biomass, the cytoplasm, starts to boil, and that makes it's like putting. I hate to even use a metaphor like this. It's like putting the cat into the microwave oven, right? I mean, that's simply where life is done, and below that, if you think of this movie, The Core, which is one of the most imbecile movie I've ever seen in my life.
Questions about that later, yeah.
Wow, they were having this funky kind of a ship that looked like a cigar. And remember, it had sort of this rotating kind of a nose, and it drilled down, and then all of a sudden, they were like 1,000 kilometers down. This gigantic cavern opened up, and it was hollow, and there were these huge crystals. Can you remember that scene? I mean, I was just laughing in my seat when I saw this. So they got out of their little ship in these flimsy little spacesuits. They looked basically like something you would wear at Halloween. Man, the pressure at 1,000 kilometers it would crush you, into a dot. But oh no, these people walking around outside as if it was outer space, and there was this hole in the ceiling, and there was lava flowing down. I mean, that was so insane.
So you're telling us that the hollow Earth theory is impossible. There's no way that the inside of Earth could be habitable.
No way.
Not at all.
No way. Because of the pressure, it would just crush any open spaces into nothing.
Well, because there's, I thought this was a conspiracy theory that had sort of been past its prime. But I was looking online, the wonders of Google, and in 2005, Stephen Curry Expeditions planned an expedition to the North Pole region to explore for a possible opening into the inner Earth. So the guy who originally started this died in 2006, and somebody else took over as leader. And this summer, they're taking, they say, 100 scientists and filmmakers to the Arctic opening.
Right.
This is interesting.
Just remember the Square of Irrational Thought, right? These are people who are delusional and incredibly stupid, or both. I mean, there is just no other way of putting this.
But they say there are streams of warm air coming out of the poles, and there's no fly zones. Exactly.
Right.
You have no idea how hard it is to look for any shred of evidence on these sites. I just need to point this out.
Yeah.
But so there's... Have you heard of this?
I've heard of it, and of course it's complete, pardon me again, bullshit. I mean, first of all, you will never ever find air coming out of the Earth. I mean, even if there was an opening, what would come out? If anything did come out, it would be lava. Right? Not air. There isn't air out there. The air is on the outside of the Earth for good reason, because it's buoyant. Right? It's a matter of specific weight. Things that weigh less float to the top, and things that are heavy that go down. So why should there be any earth, any rather air inside of the Earth? That alone is preposterous. And everything else is preposterous that these people are proposing. So, let them go on their little journey. And, we've had all sorts of wacky ideas like this in the past. We had, what was it? There was actually this doomsday cult in Russia about 2 years ago. They made me crack up. You know what happened? They were convinced that the Earth would come to an end, which happens to certain cults every once in a while. So they decided to hide out in a cave. So they went into a cave. This was like 30 or so people somewhere in Siberia. I saved a newspaper article. I just haven't looked at it in a while. And then after a little while, most of these people got tired of waiting for the Earth to, come to an end. So they left. Except for the guy who led this cult. And then guess what happened? A little earthquake happened and buried the guy who was left in that cave.
So he was right. His world ended. Right.
Yeah, but this was poetic
Prophecy
justice
fulfilled.
if I've ever seen one. I mean, this guy got killed by his own stupidity. I mean, this is just precious. You can't write a script like this. He deserved this.
If you want to get in on this conversation, 780-492-2577, extension 1, or live at skepticallyspeaking.com or at Skeptical Radio on Twitter. Okay, let's.
Does that answer the question with the hollow Earth?
Yeah.
Yeah.
I can give you also a scientific explanation why there couldn't be any hollow Earth.
I think most of our audience are on the same page. We can jump ahead here.
Something else that I was looking at before the show. Crystals. Crystals. I find that fascinating. I just want to read a quote here. I feel like putting on one of those voices. The energy field of different gemstones is influenced by geometrical form, color, and subtle variation. Each stone is made up of minute crystals which are in constant motion, thus emitting an energy signature or frequency. The gemstone's color also play a dynamic role in the stone's healing aura. The play of light and color can also play a dynamic role. Oh, sorry, I read that line. Anyway, they purify, they heal. Ancient civilizations have used them, and that's evidence. I don't know. What do you think? I know you've written articles on this.
I love it.
And I challenge you to answer it without first mentioning the chart.
Yeah.
It's a given.
When you use this voice, you could work in a blue or red color kind of an
Really?
industry
Nice.
with this voice. Amazing. Well, let me tell you what I did on that one. Again, one of the many things I have to cover in my classes is how minerals and crystals form. And a few years ago, this happens actually annually, but only once I went. There was one of these events that's called a psychic fair. It was at Northlands. And I had just finished covering crystals and minerals in class. And, my students learned things like bonding energies in crystal lattices, like covalent bond, ionic bond, and so forth. So we know what, is involved in making a crystal. And then we get this flyer, and I said, okay, let's go. Let's have an excursion. Let's go to this fair and have some fun. And so we did. And so there was, all of this, basically Northlands full of all these chakra things and people that sell this and that for holistic healing. And there are 5 or 6 or so of these little booths that sell crystals. Lots of really pretty rocks. And, I have some of them. I have one as a pendant, my car key. And, I kind of like them, but it doesn't mean I use them for healing or anything else. So to cut a long story short, I decided to test whether any of these claims that you just read out could be true. How do you test this? Let me give you an example. Imagine you want to test what the medical powers of aspirin are, right? What do? You go to 5 or so different doctors, and you hope to hear 2 things. First of all the 5 doctors have to give you the same answer. And secondly, the answer they give you has to be a rational one. Right? So let's say 5 doctors tell you, it's good for headaches and stomach aches. And fine, it's a rational claim. All of them are telling the same thing. It's probably true. But suppose all 5 doctors tell you, it makes you pregnant. What would you say? Yeah, fine, all 5 telling you the same thing, but what they're telling you is nonsense. This can't possibly be right. Well, there's only one explanation for this. It could be April's Fool's Day, right? They've colluded to make this statement. So with this logic, let's go to these, crystal people and ask them. So I decided to take quartz, which is this, translucent, glassy-looking big crystal that you can buy and looks very pretty. And I asked 5 or 4 of these people, what does this crystal do? And I didn't want to tell them that I was taking notes, so I memorized as much as I possibly could. And this was hard, as you will see in a moment, or hear in a moment. And then I stepped aside and took notes and wrote down what they had said. So here's Monica. I'm reading this off because I can't remember this. I have to, remember or remind myself. Monica, the inspirational advisor. She was saying, clear quartz attracts a lot of positive energy. I don't really know much about them. Go to Theodore, the crystal man. He's got his booth a little down the hallway, right? If you listen to the story of the crystals, you'll get the message. This is not me. This is her talking, right? I don't really know much about them, but there's lots of books about them. And what else does she say? You have to hold it and squeeze it.
Well,
things like this, right? So then, guess what? I go to Theodore the Crystal Man, right? What does he say? It means power. It means enhancement, programmability. It has the property of consistency. It gets tired when many people touch it. Yeah, that's what he says. It loses some of its energy when it comes out of the ground. It gets into this vibration with your body. I swear, this is what the guy said.
This hurts me, Hans.
All right, but bear with me. One more. Fae, the mystical treasures. Oh, it's good for healing. You should read this, right? Oh, it feels how it feels to you, right? And you have to wash them from time to time. And now it comes. She literally said this. In Atlantis, we used them as thought forms.
Oh, see, that's over the line.
A crystal destroyed Atlantis. This is when the Earth shifted its tilt for the first time. England is the last piece of Atlantis that's still there. I'm not making this up. This is what the woman said. So here we come back to, my original logic. We have asked 3 people. Did they all tell us the same thing? No. Did they all tell us anything rational? No. Every one of them gave us a different story, and every story was complete and utter bullshit. Therefore, this is all you need to have, as a proof. This whole notion of crystals having any powers for healing is, I'm sorry, bullshit. And I did a very simple test. It took me half an hour, and case closed. And yet these people make a lot of money selling these crystals. And there is thousands and thousands of people believe this nonsense, and they walk home with a little crystal that cost them $55, and they could have gotten it for 50 cents.
So, what do you think leads people to believe this? Honestly, and I understand your chart, but what I'm wondering is, was there any initial reason why people could have thought these were healing items? Are there any rocks anywhere that do anything at all?
In your mind only.
Only in your mind.
In your mind, yeah. It's you can ascribe it at a serious level. You could subscribe it to the police placebo effect. Mm-hmm. And if for example, let's take something very simple, and this is really what it all boils down to. It goes back to childhood. You have a little baby or a little child, 3 or 5 years old, who is somehow unhappy and needs to, lies in bed and is crying. What do? You give that little child a fluffy animal to hug, and then it falls asleep and has something that comforts it. You can do that same kind of a thing with an adult with a pebble of volcanic rock that you've warmed up for half an hour. And somehow this, pebble in your hands makes you feel good, makes you feel sleep better or whatever. That's what it is. But there's no energy that is, in the physical sense anyway. There's a psychological energy, if you want to call it that. Yeah, but there's no physical energy that's going from the rock to the person. Because that we could measure, and there's nothing other than the heat, if you wish.
Which is different, say, than arguably, plutonium or any radioactive rock.
Radium is what I was thinking.
Yeah, where we can actually measure something, coming out of that rock and then focus it for whichever purpose, chemo or...
Yeah.
Well, we will be right back with more of Dr. Hans Machel.
No worries.
Right after the break. On the next Skeptically Speaking, we'll be taking another look at nuclear power. With us will be Dr. Jeremy Whitlock, reactor physicist and manager of non-proliferation and safeguards at the Atomic Energy of Canada Limited's Chalk River Laboratories. Also in the studio will be Elena Shahar, founder and co-chair of Citizens Advocating the Use of Sustainable Energy, which is a member of the Coalition for a Nuclear-Free Alberta. Hear from experts on both sides of the nuclear power issue on the next Skeptically Speaking, every Friday at 6 p.m. Mountain Daylight Time, here on CJSR.
All right, everybody, we are back. We do have a couple of questions coming in here. I'm going to go with the first one here. In the movie Core, the Earth's core... I know, we love these movie ones, eh? The Earth's core has suddenly stopped spinning, causing the ionosphere to cease functioning and leading, were it not for the interventions of our heroes and their extremely improbable vehicle, to the destruction of all life on Earth. Is this possible? And could, as the movie says, could humans inadvertently cause this somehow?
No. It's simple. Again, it's to get into all the details. For that matter, this is online, and there's a wonderful write-up on a website. I can't remember the link, but there's a website that takes apart all the improbabilities, the physical improbabilities of a whole range of movies, not just this one.
Really? They have a site that does
Oh, yes.
Brilliant.
For example, just give you one example, right? In all these Wild West movies, they're always, or even modern kind of cop and robber chase movies, you get hit by a bullet, or if a person gets hit by a bullet, that person sometimes just, catapults backwards by 2 or 3 feet or even through a window. And, this just doesn't happen. If you shoot somebody, that person basically just slumps into the spot where he's standing or sitting, and that's it, because that's all the energy, the kinetic energy that bullet has. And there is hundreds and hundreds of cases like this that are neatly discussed on a website. So I'll give you that website, that link sometime later.
I would love to post that.
And there's a long discussion of The Core, that movie. And, I'm doing a little segment of that in my classes too. So where do I start with your the question there? One, for example, is that, and I think this was a really tongue-in-cheek word creation. In the beginning of the movie, when they make this ship that they drill into the earth, can you remember what the name is of the material that they made it from? It was called unobtainium. This was such a wonderful slapstick, and most people didn't pick up on it. And I went there with my class, I had 15 or what students around me, and they just bought most of the stuff in the movie. They were crying when the heroes were dying close to the Earth's core and all of this nonsense. It was funny like hell. But I wonder how many people actually believe this. So having said that, okay, we know, this is hard science now, all right? We know that the Earth is composed of spheres or shells. We know that from seismic. There's shock waves, basically, that you can either artificially generate at the surface of the Earth, for example, with a nuclear detonation, or there's earthquakes, which are very shallow, relatively speaking, to the globe's diameter. And these shock waves go through the Earth, and they do this in a certain manner, in a certain velocity, and then they come out at various spots around the globe in all sorts of places where they're measured. And with the right understanding and the right computers, from that you can deduce very easily and straightforward that there is a thin shell that we call a crust, which is about 65, 90 kilometers. It varies a bit in thickness. This is like the peel on the apple. Then there is a fairly thick shell below that, which is called the mantle, which goes down to 2,900 kilometers. That's solid material. Then comes a shell, then comes the core, the third, the nucleus of the Earth. And the outer part of the core is actually liquid. And that's true in as much as the movie goes. There is a liquid mass of material down there, and we actually know what it is. It's a mixture of molten iron and nickel. We know that from the way these seismic waves go through that material, because from that we can calculate the velocity and the density and the material's composition. So that said, there's no way these swirling convective motions in that molten hot metal can get stopped by anything we do at the surface. That's just preposterous. This is like saying, let's say, we have a mosquito flying over Edmonton and it's going to make the swimming pool in the river valley spill over. That's as preposterous as this notion is. Whatever we do here at the surface, we can't possibly influence the convection of metal in the core.
I'm going to have to jump to another one really quickly here, but conceivably, if you could make a very, very big drill and get close to that core, could they throw off the system?
No. Again, imagine taking in that metaphor, that would be taking a pin, like, a tiny thin pin from an acupuncturist and go into the middle of a melon. And, on a melon, which is like the football size, something like this. I mean, what can you possibly do to that melon in the middle with that tiny little... It's just preposterous.
Fair enough. Okay, we'll jump to the next one here. Is there an easy way to falsify the expanding Earth theory? Have you heard of that one? The expanding Earth theory?
Yeah. An easy way to falsify it. That's a very complicated question in a way. I wouldn't say it's easy, but it can be falsified on the simple grounds of, again, looking at the geological record. We have all sorts of rocks that we can trace back through time with radiometric dating. We know, for example, that the Earth was basically the same size ever since it was formed. From something very straightforward. This is direct evidence from how many days does it take for the Earth to rotate around the sun, in other words, the seasons. And, which was, by the way, many more days in the past. A year was about 400 or 450 days about 1 billion years ago. And the Earth's rotation itself has also slowed down through friction between basically the Moon and the Earth, which makes the tides. And as you know, the water is sloshing around the globe basically because of the attraction of the Moon. And this water-Earth interaction is friction conditioned. In other words, the Earth's rotation slows down, which makes the days a little bit longer. We know this from hardcore evidence. We can, for example, take corals that grew in 400 million years ago and count how many growth rings they have. So we know from hardcore evidence, I mean, this is a huge body, a complicated question that you just asked, but we know from a huge body of scientific evidence that the Earth was basically the same size, but just slowed down a little bit in its rotation over the last 400 million years. But that excludes by default, if you wish, that the Earth is expanding, because if the Earth were expanding, then its rotational velocity would be completely different, its density would be different. So there's a multiple set of arguments we could make. You did pose a complicated question.
Yeah, I know. It's always tricky on the short little radio hour we have here. The last question, I'll just give it a shout-out, but we're not going to answer it at all. Let's just say it discussed the flat Earth theory, and I don't even want to go there with a 10-foot pole with a minute left in the show here. So
thank you so much for the emails. And that is all the time we have today. So thank you so much, Hans, for being on the show.
It was fun.
I would love to take a class from you. That would be brilliant.
Anytime. Or invite me back to the show if you have some time.
Well, actually, just to let everybody know that actually is Hans's specialty is global warming. So we might have him back.
Not quite. In all fairness, I teach global warming, but it's not that I'm not a specialist in it. I'm as much a specialist as anyone in my department.
More than we know.
Yeah. We are, again, remember, Earth and atmospheric sciences, we are the kinds of people who do the research and transmit this knowledge. That doesn't mean every one of us is an expert, but we certainly know more than, the people who are around this square of irrational thought.
And on that note...
For sure. I'm going to give one event a shout-out really quickly here. It's the Center for Inquiry's multi-group on-topic night. We'll be discussing a variety of issues with some speakers and roundtable discussion. That will be at 7:30 on June 8th at the Accent Lounge just off White Avenue. And on that note, have a good night, everybody.
And thanks very much to Jill Powell for being on the show. Your ranting is always appreciated.
We do love it, yes. Have a good night, everyone.
Night, everyone.
America doesn't exist. The moon is painted on the sky. Things sometimes fall up, but you never see. And everything you believe is a lie.
Dinosaurs were invented by God as a test. Our bodies don't rot when we die. The hippies are working for the government. And everything you believe is a lie.
Everything you believe is a lie.
There are wee tiny dwarfs inside your TV.
And nobody cares when you cry.
Your mother resents you. She wanted a girl.
And everything you believe is a lie. Lie, la, 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 lie, lie. Everything you believe is a lie. Lie, la, 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 everything you believe is a lie.
It's been years,
but I never loved you,
and I never will.
though I've tried.
We'll never get married.
I'm dating your sister, and everything